And what I'm trying to do is show you natural climate, and natural climate ebbs and flows. If you're thinking Western, and I think we all do around here, it's always moving like a horse. And you know how it is? If you don't match the movements of the horse, you're going to fall off. So that's what I'm trying to do. I'm trying to tell you how things are moving. First of all, as you may have noticed, winter was, shall we say, a little brisk. What happened is we had an extremely cold winter because of volcanoes. There were 2 volcanoes that went off in 2011 in the poles. And they put so much dust and debris into the atmosphere that they cooled off the poles. And when that cold polar air hit us, I mean, any year where polar vortex becomes a household word, you know you're in trouble. It's going to create a volatile spring. Something else I talked about. The oceans make up 70% of the Earth. When you're talking about climate, the oceans are not the elephant in the room. They're the room. We're in it. And the Atlantic Ocean is really hot. And this is a long-term heating trend. And what it does is it creates hotter summers and stormier winters, springs, and falls. So we are in a long-term cycle of more extreme weather where it's hotter in the summer and tends to get colder in the winter. And then exciting in between. The next thing to look at is the Pacific. The Pacific is 30% of the globe's surface. Right now, the Pacific is neutral, but it's in the process of change. According to scientists, they are saying 50% statistically. When you talk to them, and I talk to them, they say 60%, and I think it's closer to 80%, chance of summertime El Nino conditions. And when you have summertime El Nino conditions, it brings rain. And if it turns into a full-scale El Nino, it brings a lot of rain. But for the summertime, we're talking about good rains for central and western Texas as the overall pattern, but unfortunately, not so much for the Gulf, Panhandle, and Louisiana border. It's when the El Nino develops and gets stronger that you really start seeing the rain. So, even if there's an El Nino, it's not the end to everybody's problems in the summer. But I'll go into that more. Finally, this has been the long-term message, and I've been telling your group since, I think since the 90s. We are in a trend where the Pacific, 30% of the globe's surface, has changed. There's a cycle called the PDO, Pacific Decadal Oscillation. Now, I just talked to the Cowboy Hall of Fame, so I said if you want to remember PDO, think pretty dry Oklahoma. And it has changed. It started to change in 1999, and it tipped in 2006. And it is creating drier conditions here in the Southwest. But not just the Southwest. It is destabilizing rain patterns, and with it, agriculture worldwide. And the good news is you have a better infrastructure than most of your competitors in the rest of the world. Basically, natural climate is shaped by 3 things. How much radiation we get from the sun, because the sun goes through cycles, and the energy from the sun is what's used for the global weather system. Secondly, where does that radiation fall? They had a multi-million-dollar study, and they proved that if there's clouds overhead, it gets cooler. Okay, if you have volcanoes, big volcanoes, they can put enough debris up there that they can really cool things off and change the climate. And we are in the middle of a time of volcanoes. So we've had some very strange weather patterns. Finally, once that radiation reaches the Earth, where is that heat stored? Where is that energy stored? And you know what? 70% of the globe being ocean means most of that heat is stored in the oceans, and the liquid ocean carries the heat all around, and that's what I track. Because the secret to understanding natural climate is follow the energy from the sun through the skies to the Earth's surface. And that's what I do. I'm a historical climatologist. What does that mean? Well, it means, for one thing, I'm not looking at models and making predictions. I'm looking at the factors that are currently shaping the weather, and then I'm going back through history. And I have a lot of data on history. I have monastic records. You may think of a monk as a holy man. I think of him as an agribusiness man with a flair for record keeping. And I have some of those records going back to the 800s. I look at tree rings. I look at ice cores. Heck, I even look at layers of mud. And according to scientists, when you put those together, you have a year-to-year climate record of what the weather was like for 100,000 years. So I find the 5 years most similar in factors to what we're looking at. And I tell my clients, this is what happened 80% of the time. So you are not having somebody forecasting, you're having somebody giving you perspective so you can make informed decisions. You can say, okay, in the past, this is what's happened. I bet there's a good chance it's going to happen again. I want to brace myself. So that's how I work. Okay, let's start looking what actually shapes the weather. First, let's look at volcanoes. A large volcano, if it puts debris up into the stratosphere, and that's this high upper layer, it is so quiet there that if ash and debris gets up there, it lasts for 1 to 3 years. If it's really big, it can last up to 7 years. They had one volcano, went off on my birthday, April 5th, 1815, a little before I was born. And it was so huge, it put 35 cubic miles of ground up ash 75 miles high into the atmosphere. And the next year was called the year without a summer because they had blizzards of snow in June, July, and August south of the Ohio River. Notice, this is volcanic ash. It's not like that ash when you burn wood. It's volcanic glass. It reflects back incoming sunlight. And then, notice this picture over here? It accumulates water. And you get, here's a normal raindrop. When you have that much debris in the atmosphere, the water gets divided up, and so you get micro droplets. So it forms clouds. When Pinatubo went off, that was 1991, and it went off in the Philippines. 5 eruptions between 15 to 25 miles high. And when it blew up, it formed clouds as large as the state of Montana, which sounds impressive to almost every state except Texas. But clouds the size of Montana, 10 to 15 miles thick. And it filtered out so much incoming sunlight that the Earth cooled 1/2 of 1 degree. Again, it doesn't sound like much, but I have a lot of clients in Alberta. See, I find cattlemen everywhere. And he phoned me the next year, and he said, look, I have a foot of snow in my field, and it was the 3rd week of August. I just got back from Ontario. Their crops never ripened that entire year afterwards. Green in the fields until the winter snow covered them. So you put the debris up, it floats in the atmosphere, reflecting back incoming sunlight, creating cooler conditions. It gathers water, forms clouds, and they block out even more sunlight. And finally, when it rains, it's super heavy rains. Pinatubo went off in 1991. In 1993, when all that debris finally rained out, you had the huge flood, the 1993 floods in the upper Mississippi. After big volcanoes, first you have cold or changes in weather, then you have heavy rains. Why is it I'm not hearing anybody looking sad at heavy rains? Why is this important? Well, you can go decades without a large volcano. But in 2011, we had 2 huge volcanoes that went off in the polar region. Grímsvötn in the North Atlantic, Cheveluch in the North Pacific. Now, you have to realize, this was having one in the Atlantic, one in the Pacific, in the poles. The last time that happened was 1783, 1784. You have been experiencing weather that has not been seen since the 1700s. If you think it's been weird, the answer is, you're right, it's weird. But that debris is in the process of falling out. Also, notice, after a long quiet spell, there's a lot of moderate volcanoes going off. And a large volcano can alter climate for a couple of years. Smaller volcanoes put the debris in a cold front, and they cool off the single front. They affect weather for maybe 1 to 2 weeks. 2011, 2 large volcanoes erupted. They started cooling the Arctic. Last summer, the Arctic was so cold, it was the coldest ever recorded. We've been keeping records only since the 70s, but we've never seen conditions as cold as last summer. The ice grew 900,000 square miles. What? You mean they weren't reporting ice growing? It grew. And I told my clients, look out, if you think it's cold up there, wait till you see how it feels down here. When the volcanoes first went off in 2011, they cooled the air, they changed air pressure, and wind is shaped by air pressure. So the winter of 2011, 2012, the winds were so strong that they pinned all that cold air north. And remember 2012, how hot it was? It's because the Arctic air never escaped south. It kept staying trapped up in the north. You know, we were hot. Alaska, Fairbanks had, what, 29 feet of snow in their streets. I like to say they took the hit for the lower 48. Well, eventually, those winds weakened. And when they weakened, the cold air finally escaped south. And as a result, that record cold air, when it reached North America, look what it did. And also, notice the pattern. Center of the country, east, center, east. None of it's going west. We're having none of that cold air and ash causing storms and rainfall in the west of the Rockies. Now, that's not the end of the story. Guess what? We had another volcano go off. February 13th. A huge volcano went off in Indonesia, in the tropics. It was 18 plus miles high. The sulfur and debris cloud from that was bigger than the entire island of Java, where it erupted. And by the way, Java is the center of rice production for Indonesia. So, see, isn't that cool? This is a picture, a satellite went directly overhead and looked straight down at the eruption. And where you're seeing white, you know, you can see right down there, the bottom of where the volcano's going off, then it's red, then white. That is where the debris is entering the stratosphere. Isn't that a huge amount of junk up there? Scientists are still studying the impact. And there's a debate. There's some scientists who say there's not enough sulfur. It won't affect climate. I look at history, and I bet it does. Mark Twain had a saying, liquor's for drinking and water's for fighting. And if you're Muslim, you can't drink the liquor. Which brings us back to our conclusions. Climate change ebbs and flows. It's a somewhat predictable pattern, and you can adjust to it if you know what's coming ahead of time. It's been cold because of polar volcanoes. But the good news is it's been 3 years, their impact is going to be dying off. The Atlantic is hot. It's going to be bringing you heat. It's going to be bringing you storms. The Pacific is expected to bring you El Nino. It'll bring some more rain in summer, but the longer it lasts, the more rain Texas gets. And you end up with the problem of mud. I'm sorry, but mud sounds better than drought. Maybe because I haven't had to wade through that much mud lately. And finally, we have reached a tipping point. The PDO has changed conditions for the world. But you know something? We went through the 50s, and America was one of the wealthiest countries on earth, even though they had lousy climate. We fed the world. Most of the rest of the world doesn't have the infrastructure, and they're having the same climate problems. There is a saying, may you live in interesting times. If you're in China, it's a curse. If you're Texan, you're just oddball enough that interesting sounds interesting. And that's what we're going to have, interesting times. Thank you.